How to build a Blackgates Sweep P 5-inch gauge locomotive, part 17. Testing the strength of the JB Weld high temperature epoxy putty using a hammer. It would appear to be very strong stuff indeed. Grinding off the excess and cleaning up the port face using a sheet of 400 grit wet to dry sandpaper. And checking the fit of the slide valves and rods. Over 24 hours has elapsed since I applied this high temperature JB Weld epoxy putty. Whenever I use 2-pack epoxy putty, I always mix too much and have a bit left over, but in this case it's going to be quite good for a test. Using a hammer. I rolled the excess epoxy putty into a ball, then pressed it down onto a piece of wood so it didn't roll away. Bring on the hammer. I moved the ball around on the piece of wood and kept hitting it with the hammer, and it didn't fracture, it didn't crack, and nothing fell off it. And when I put the ball back on the piece of wood, it rolled until the flat surface where I'd pressed it originally was at the bottom. I'm now in the outer part of the workshop very carefully removing the excess epoxy putty from the cylinder casting. I'm being very gentle with this, and the belt on the belt sander is not a new one, it's quite worn. I would never use a new belt for this job because a new belt cuts very well, and that's the last thing you want it to do. Although this doesn't come across in the video, I'm holding the cylinder away from the belt slightly. I'm not putting any pressure on the cylinder casting. With a job like this, it's very important to look at the part frequently so you can see how far you've gone with it. All of the epoxy putty is now level with the port face, so it's time to take the cylinder back into the other part of the workshop for some more attention. Even a worn belt on the sander is too brutal for this job. Here I'm going to use some 400 grit wet to dry sandpaper. It's very important to make sure that the wet to dry sandpaper is on a flat surface. I could use my surface plate, but that's quite heavy and at the other side of the bench. Instead, I'm wrapping the piece of 400 grade wet to dry sandpaper around a steel plate. Before I continue the operation though, I just need to clean up the exhaust port in the centre, and for this I'm using a drum sander in this very useful Proxxon motor tool. This clip shows the cylinder after I carefully used the belt sander to flatten everything. I suppose I could have fitted it in the milling machine and spent ages levelling it up, but it's more than level enough by using the belt sander and my calibrated eye. For the next part of the operation I need some lubrication. I'm going to try some of this Myford slideway oil. I poured some onto the wet to dry sandpaper and spread it out with a brush. The next part of the process is very tedious and very boring, and you need a lot of patience. And also you can't really rush it because you don't want to spoil it. Remachining a new cylinder at this stage really would be a pain. The whole point of buying this part-finished engine was to speed up some of the more tedious processes. I don't have to make things from scratch. Some of them will be repairs, some of them will be modifications. Either way, it's a good learning curve for anyone who wants to know. I found that the viscosity of the slideway oil was slightly too high. And in this clip I'm adding some 3-in-1 machine oil, which should make it a bit thinner. The clips that you're watching are heavily edited. This process took about 15 minutes in total. If you look carefully at this clip, you will see the direction of movement is normally from left to right, or right to left. I'm purposely doing it this way because I want any scratches on the port face to be at 90 degrees to the direction of travel of the valves. I kept having to change hands because my arm was aching. I needed a bit of a change, so I took one of the slide valves and rubbed that up and down the wet to dry sandpaper. The slide valve machining isn't brilliant, and the marking outlines on the front surface of the valves are far too deep. I'll be able to get rid of this in time by doing a bit more of this sort of thing. And just like the cylinders, I'm rubbing the valves crosswise, because once the valves are sliding up and down the ports, The valves and the port faces will wear in and everything will become smooth. Even after rubbing these valves on the wetted dry sandpaper for a short time, you can clearly see the marking outlines. And also the valves are not perfect, they're not symmetrical, and the edges aren't rounded properly. I wanted to make sure that the JB weld on the port face was perfectly level, and I did that by rubbing one of the valves across the port, and as you can see, there are no dry patches on the JB weld. The epoxy putty repairs are equally as flat as the rest of the port face. What you've seen was only just one cylinder. This is the other one, but I'm not going to go through this in detail. It's exactly the same process as you've just been watching. The only difference is it's the other cylinder. Everything's fitting together quite well, but there is still a problem with the valves. There are two things wrong. One is the drive block is made from steel. This will rust, so I'm going to change that and make it from a piece of brass or phosphor bronze or something like that, something that doesn't rust. And the other problem is the slide valve is not the correct shape to move full distance within the steam chest. This will need some modification. But I won't be doing that in this episode, that will be in the next one. As always, stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.